Good morning, class. Here's chapter 3, derivatives, section 3.4, the product and quotient rules. So we looked at derivative and rates of change, the derivative as a function, basic differentiation formulas, and now the product and quotient rules. Reminding everyone that rise over run. There are various formats of writing rise over run, the average rate of change of y with respect to x. As q approaches p, it gives rise to the tangent line. So the tangent line is the limiting position of secant line PQ as Q approaches P. So to find the equation of a tangent line, we need to find the slope. To find the slope, we find the limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. We call it f prime of a. Various formats for lines. We use the point slope, and at a comma f of a, we end up with y minus f of a equals f prime of a times x minus a, or simply put, use the point slope. A general form for differentiation, instead of saying at a specific point a, rather a general point x gives rise to the differentiation formula. The derivative function f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So we looked at various formulas, the definition for differentiation. The derivative of x is 1. The derivative of c times f of x, you can put the c out, comes from the limit. And the sum and difference rules. The derivative of the sum is the sum of the derivatives. The difference of the derivative of the difference is the difference of the derivatives. And what you're looking at here are basic differentiation formulas that we've discussed. The derivative of any number, any constant is 0. Power rule, the derivative of x to the power of n is nx to the power of n minus 1. The derivative of k times x is k, where k is a number, is a constant. The derivative of e to the power of x is itself. Sine is cosine, cosine is negative sine. And we will look at this furthermore today. The derivative of tan is secant squared. Cotangent is negative cosecant squared. The derivative of secant is secant x times x. The derivative of cosecant x is minus cosecant x, cotangent x. And now the product and quotient rules. The derivative of f of x times g of x is f prime of x g of x plus g prime of x f of x. The derivative of f of x over g of x is f prime of x g of x minus g prime of x f of x over g of x squared. Notice what I like to use. I like to use the shorthand notation here. The reason why is when I want to differentiate the quotient rule, I use the same thing for the numerator. I change it to a negative. So fg prime is f prime g plus g prime f. So f over g prime, I use the same thing and I change it to a negative over g squared. The order by which some of you have learned this in previous courses, it might be slightly different, but this order will help memorize the quotient rule. Now, quickly, the proof for the product and the quotient rule is at the end of the power point. But just to give you an idea, first and foremost, this is the order that you've seen. The derivative of f times g is f times d dx of g of x and g plus g times d dx of f of x. But as I mentioned, the way I put it, it's, I believe, easier to memorize, especially the quotient rule. So by analogy with the sum and difference rules, one might be tempted to guess that the derivative of a product is the product of the derivatives. We can see, however, that this case is wrong by looking at a particular example. For example, if f of x is x and g of x is x squared, we know that by the power rule, the derivative here is 1, the derivative is 2x. If we multiply these two, we get x cubed, and we know the derivative is 3x squared. Now, if a prime g prime, that means multiply these two, it's 2x, which is not the answer. So f g prime is not equal to f prime g prime according to analogy. However, the shorthand notation f prime g plus g prime f prime g, that means 1 times x squared, plus g prime f, that means 2x times x, that adds up to x squared plus 2x squared equals 3x squared, which is the correct answer. I want you to do this example. I want you to do this at home. Two different ways, of course. One is to distribute and use the power rule. The second is not to do so. Rather, this is the f function, this is the g function, and use the uh, product rule on that. And again, I will go with the easy way. So as a warm-up example, we want to differentiate y equals x to the power 4 minus 2x cubed minus 7 times 3x squared minus 5x. Now, granted, we can distribute and use the power rule on that, but I want to go with the uh, product rule. So let's say the first one is the f function, the second one is the g function. So we're going to use the product rule, f prime g plus g prime f. So f prime for x cubed minus 6x squared times g, just the g function, 3x squared minus 5x, plus g prime, this is 6x minus 5 times f, x to the power of 4 minus 2x cubed minus 7. Bear in mind, I'm asking you not to simplify, of course, at this step. I want you to do that at home, of course. The point being, when you differentiate, mostly we have only one step, as it's the case here, and then we have several steps to finish it off. And this is not a finished job. This is just a warm-up example. Okay, everybody? If h of x is x times e to the power of x, find h prime, and part B, find h double prime. So first and foremost, notice is the product of x and e to the power of x. We put a raised dot in between. So two functions. The first one is f, the second one is g. We are going to use the product rule. F prime g plus g prime f. So f prime is simply 1 times g, which is e to the power of x, plus g prime, the derivative of e to the power of x is itself, times f, which is x. And obviously, we can take the common factor of e to the power of x. So this is it as far as calculus is concerned. E to the power of x is out, 1 plus x. That is the factor format. We want to differentiate it again to get to h double prime. We're going to differentiate this piece. So this is also using the product rule, f times g. So we need f prime g plus g prime f. F prime is itself e to the power of x. G is the parentheses 1 plus x. Plus g prime, the derivative of the parentheses is simply 1 times f, which is e to the power of x. And I hope you see that if I factor the e to the power of x out, I get x plus 1 or x plus 2. By the way, 1 plus x or x plus 1 makes no difference, right? Y equals x squared sine x. This is the product of x squared and sine x. We put a raised dot in between to emphasize that. And therefore, f times g. So the answer is f prime g plus g prime f, and to do so, f prime, the derivative of x squared is 2x times g, which is sine x, plus g prime, the derivative of sine is cosine times f, which is x squared. So 2x sine x plus, you put the x squared in front because I don't want anybody to be under the assumption that this is x cubed, because x is the only argument of cosine. Therefore, you put the x squared in front. We are done. Let's go with the quotient rule. Again, a warm-up example. I'm using the same f and g, but this time is f over g. And again, I ask you to simplify it later on your own. I want to go over one and only one step, which is using the quotient rule for the differentiation to differentiate one step of calculus. So f prime, so y is x to the power 4 minus 2x cubed minus 7 over 3x squared minus 5x. So f prime, 4x cubed minus 6x squared times g, the denominator is 3x squared minus 5x. Minus g prime. The derivative of the bottom is simply 6x minus 5 times f. The numerator, x to the power of 4 minus 2x cubed minus 7, over g, the denominator, in a parentheses, squared. And we're done. Again, please understand, we are done with calculus. We have a few more steps to go to finish the job. This is not a finished job, everybody. I just wanted to emphasize that the calculus step is really not difficult, and we don't have a lot of it. All right, we want to differentiate y equals x squared minus 3x over x minus 1. We are going to use the quotient rule. Therefore, we're going to call it f over g. So we need f prime g minus g prime f over g squared. Speaking of f prime, we get 2x minus 3 times g, simply the denominator x minus 1, minus g prime, the derivative of x minus 1 is just 1, times f, just put the numerator next to it, x squared minus 3x, and then the g squared, x minus 1 inside the parentheses, quantity squared. And this is the extent of the calculus. We are done. So let's simplify the numerator. The way we do that, of course, 2x times x is 2x squared, minus 3 times minus 1 is plus 3. The middle term here, everybody, these two, negative 3x, these two, negative 2x. So we get negative 5x here. In other words, 2x squared minus 5x, negative times negative plus 3. This is minus x squared. This is plus 3x. And so we want to combine what we can in the numerator. So the like terms like 2x squared and minus x squared, they add up to x squared. Negative 5x, positive 3x, they add up to negative 2x. And the question is this the final answer can be simplified? Number one, you have to really check to see if you can factor this. Number two, even if you can factor, it's important to have a factor of x minus 1 to simplify. Otherwise, it can't be simplified. So even if you can factor it, but it doesn't have a factor of x minus 1, it cannot be simplified. So I'm going to remind you how we know we can simplify this or not, we can factor it or not. You recall the quadratic formula ax squared plus bx plus c equal to 0. And x is minus b plus minus a squared of b squared minus 4ac over 2a. B squared minus 4ac is called the discriminant. If the discriminant is positive, you have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. If b squared minus 4ac is 0, you have one real solution or a rational solution. If it's negative, you have no real solution. You have two complex solutions in the form of a plus minus bi. Furthermore, if b squared minus 4ac is the perfect square number, then ax squared plus bx plus c can be factored. So if we look at this one, the numerator, everybody, a is the coefficient of x squared 1, b is the coefficient of x minus 2, c is the constant 3. B squared, that means negative 2 squared, minus 4 times a, which is 1, times c, which is 3, and we get 4 minus 12, which is negative 8. This not only can't be factored, if you happen to set it equal to 0, you get two complex solutions. So it can't be factored, and we are done. So some information from algebra. Now we want to differentiate h of x, which is square root of x, e to the power of x. First and foremost, in order to take care of this, square root of x is x to the power of 1/2. We put it in this format for the sake of differentiation. And for that, being able to use the power rule. Also notice I can put a raised dot in between, and it's the product of f and g, where f is x to the power of 1/2 and g is e to the power of x, and we are going to use the product rule for differentiation on that. So f prime g plus g prime f prime is 1/2 x to the power of 1/2 minus 1, which makes it negative 1/2, times g, which is simply e to the power of x, plus g prime f. G prime is itself e to the power of x, and f is x to the power of 1/2 or square root of x. This is it. Done with calculus. Now we have a couple of steps to finish the job. We're going to go over that. So first and foremost, x to the power of 1/2 is square root of x. X to the power of negative 1/2, you put it down here, make it square root of x. We are using negative exponential rules. For example, a to the power of minus n is 1 over a to the power of n, or 1 over a to the power of minus n is a to the power of n. So you move the negative exponent. And so having said that, this is 1 over 2 square root of x times e to the power of x, and this is e to the power of x square root of x. Now, we want to combine them in a manner that later on, when we want to set this equal to 0 to be able to solve and factor, therefore, we notice this one has the denominator 2 square root of x. This one doesn't, so we can multiply this by 2 square root of x over 2 square root of x, so they both have the same denominator. In fact, they both have the same denominator and the same e to the power of x. So all you have to do, let's see what color I want to use here. Combine this into 2x, because it's square root of x, square root of x, that's x. And so this is the same as this one, this is the same as this one. And so you rewrite this as 1 over 2 square root of x e to the power of x plus 1 over 2 square root of x e to the power of x times 2x. So this piece is identical. You can take it out as a common factor. This will provide 1. This will provide 2x. And h prime of x becomes 1 over 2 square root of x e to the power of x times the parentheses 1 plus 2 to the power of x. All right. So again, the emphasis is that there's one step of calculus and then several steps of algebra. Y equals e to the power of x over 1 plus x. We want to differentiate that. It's a fractional form, and we want to go with the quotient rule, so we're going to call this f over g. Therefore, the answer is f prime g minus g prime f over g squared. Again, in order to have an easy time when you do your assignments or quizzes or your exams, write the formulas from the memory and then follow them. So if I want to do this, I'm going to write this formula for me. And I'm going to follow that. So f prime is itself e to the power of x times g, which is the denominator 1 plus x, minus g prime, 1 is 0, x is 1, so minus 1, times the numerator f, which is e to the power of x. Over g squared, just write the denominator in a parenthesis and a square. And again, this is it. You're done with calculus. You want to simplify the numerator. So this is e to the power of x. This is e to the power of x times x. This is minus e to the power of x. These two cancel each other. And we put the x in front. It's a better format. Y prime becomes x e to the power of x over 1 plus x quantity squared. Y equals 1 plus sine x over x plus cosine x. Again, we notice it's a fractional format. We can use the quotient rule for derivative. So we're going to call it f over g. So the derivative is f prime g minus g prime f over g squared. So we're going to start with f prime. 1 is 0 sine. The derivative of sine is cosine. So we put cosine x times g, just the denominator x plus cosine x. Minus g prime f, that means differentiate the g. This becomes 1 cosine, the derivative is negative sine. So 1 minus sine x times f, the top function is 1 plus sine x over g, that means x plus cosine x quantity squared. And again, we are done with calculus, everybody. We are going to simplify this. Cosine x times x is x cosine x. This 2 is cosine squared minus. This is a minus b, a plus b, reminding you a minus b, a plus b are conjugates. The product is a squared minus b squared. So minus, this becomes 1 squared, which is 1 minus sine squared. So x cosine x plus cosine squared minus 1 minus sine squared. The denominator is not changing. Now, reminding you of some identities known as Pythagorean identities in trigonometry. Sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. So if you look at the first one, sine squared plus cosine squared is 1. Therefore, 1 minus sine squared must be cosine squared. This can be replaced by cosine squared, everybody. These two cancel out. We are left with x cosine x over x plus cosine x quantity squared, and we are done. So that's pretty straightforward, everybody. Differentiate g of t is t minus square root of t over t to the power of 1/3. And I'm asking, do we need to use the quotient rule? Now, it's extremely important for you to know that if you have to use the quotient rule and try to avoid it, normally it becomes more difficult. On the other hand, if you don't have to use the quotient rule, you don't recognize it, again, it becomes more difficult. And should we use the quotient rule? The answer is no. Why is that? You just make up two fractions. This one is one fraction, t over t to the power 1/3. This one is the second one, and of course the numerator is square root of t. We write it as t to the power of 1/2. So this is your algebraic step. The next algebraic step uses the quotient rule for exponentials. This has exponent 1. So t to the power of 1 minus 1/3 minus t to the power of 1/2 minus 1/3. In other words, this is 1 minus 1/3. This is 1/2 minus 1/3. And now we are ready to use the power rule of differentiation. And so we get 2/3 t to the power of 2/3 minus 1, which is negative 1/3, minus 1/6 t to the power of 1/6 minus 1, which is negative 5/6. Each of these, using negative exponential rule, they go down and both of them become positive. So we have 2 over 3 t to the power of 1/3, this piece, minus 1 over 6 t to the power of positive 5/6. So as you can see, this is the only calculus step. This one, this one, this one, this one, they are all algebraic steps. The derivatives of trigonometric functions, we said the derivative of sine is cosine, cosine is sine, tangent is secant squared, and so forth. Now, the derivative of tan x is secant squared, we want to prove that. So if y or f of x is tan x, we want to show that its derivative is secant squared. To do so, well, we go back to trigonometric identities, tan x is sine over cosine. In fact, I'm going to remind you, tan x is sine over cosine. It is also 1 over cotangent x. Cotangent is cosine over sine. It is also 1 over tan x. Secant, by definition, is 1 over cosine x, and cosecant is 1 over sine x. So we write it in this form, and we call it f over g. Now we can use the quotient rule for differentiation. Which means f prime g minus g prime f over g squared. So f prime, the derivative of sine, is simply cosine times g, which is cosine itself, minus g prime, the derivative of cosine, as you know, is negative sine. So minus negative sine times f, the top function is sine x, and then over g squared, the bottom function squared, cosine squared. And again, done with calculus, we are going to use algebraic techniques, trigonometric identities to finish that. Having said that, you recognize this one as cosine squared, this one as plus sine squared, and the numerator is one of those Pythagorean identities, sine squared plus cosine squared, or cosine squared plus sine squared, makes no difference, is equal to 1. If 1 over cosine is secant x, 1 over cosine squared must be secant squared x. Therefore, we prove the derivative of tangent is secant squared. We continue with the derivatives of trigonometric function. Now, this time we want to prove the derivative of secant x is secant x tan x. That's what we want to prove. So we let y or f of x be secant x, and secant x is 1 over cosine x. Therefore, we are going to write it as f over g and use the quotient rule of differentiation on this one as well. F prime g minus g prime f over g squared. F prime, any number, the derivative is 0, times g cosine x minus g prime, the derivative of cosine is negative sine, times f, the numerator is 1, over the g squared cosine squared x. And again, we are done with calculus. Let's finish the job. We notice this is 0, this is positive, so sine x, that's all we have in the numerator. And we remember from trigonometry, when we wanted to prove trigonometric identities, we would manipulate things. In this case, we are going to go with secant and tan. We are going to write this as 1 over cosine, sine over cosine. 1 over cosine is secant x. Sine over cosine is tan x. And we just proved the derivative of secant x is secant x tan x. I recommend you work on cotangent x. Write it as cosine over sine and prove its derivative is negative cosecant squared x. For cosecant, write it as 1 over sine and prove that. That would be a nice way to practice this concept. Find an equation of a tangent line to the graph of the function y equals x over 2x minus 7 at 3 comma negative 3. In order to find equation of any line, we need two things. We need a pair x comma y, which is given. We also need the slope that is missing. How do you find the slope? You differentiate and then you plug in x to find the slope. Please understand, just the derivative is not the answer. So first notice this is a fractional format, more specifically rational format. We write it as f over g, and we use the quotient rule on that. F prime g minus g prime f over g squared. So f prime is 1 times g, the denominator is 2x minus 7, minus g prime, the derivative of the bottom is simply 2, times f, the top function is x, and you put the bottom here and square it, 2x minus 7 quantity squared. And this is it as far as calculus is concerned. Everything else is algebra. So you're going to simplify the top. You get 2x minus 7 minus 2x. So 2x minus 7 minus 2x means we can get rid of those two. Which means y prime is negative 7 over 2x minus 7 squared. This is not the slope. This is the derivative function. What is the slope? Plug in the x coordinate. In other words, y prime evaluated at 3. So let's plug in 3 instead of x. When we do so, 2 times 3 is 6, minus 7 is negative 1. Square it, you get positive 1. Minus 7 over positive 1 is minus 7. Y minus y1 equals m times x minus x sub 1, which means y minus negative 3 plus, which makes it plus 3, equals m negative 7, x minus x sub 1, x minus 3. Y equals minus 7x plus 18 is the final answer. This pair belongs to the function, also belongs to the tangent line. You can check it works, which means this part was done properly with no problem. All right. H of m is 9, m minus 7 over 5, m plus 4. And y, I want you to try differentiating that because on purpose I'm using a variable normally we don't use. Normally we go with xt theta, but in science we can use any variable, in this case m, that means the derivative of m is 1. That means m is the independent variable. We notice the fractional format, so we're going to go with the quotient rule. We're going to call it f over g. So we need f prime g minus g prime f over g squared. So f prime is simply 9. G is the denominator, 5m plus 4. Minus g prime is just 5. Times f, the numerator is 9m minus 7. Over g squared, the denominator, 5m plus 4, quantity squared. All we have to do is simplify the numerator. So we're going to distribute and we get 45m plus 36. Minus 45m plus 35. 45m and negative 45m cancel each other. We get 36 and 35. They add up to 71. So 71 over 5m plus 4, quantity squared. That's the final answer. Find an equation of the tangent line to the graph of the function y equals e to the power of x cosine x at 0, 1. In order to find an equation of a tangent line, we need the slope and a pair. The pair is given. To find the slope, we are going to differentiate. To differentiate, we notice that we have to use the product rule. So this is the product of e to the power of x and cosine x. We put a raised dot in between. So f times g. So y prime is f prime g plus g prime f. F prime is itself e to the power of x times g, which is cosine x, plus g prime, the derivative of cosine is negative sine. So plus the parenthesis negative sine x times f, which is e to the power of x. And we can factor the e to the power of x out, we get cosine minus sine. So y prime is e to the power of x, parenthesis cosine x minus sine x. This is the derivative function, everybody. But it's not the slope. We plug in and we replace the x with 0, becomes the slope. So m is y prime evaluated at 0, which means e to the power of 0, cosine of 0, minus sine of 0. This is 1, this is 1, this is 0, and the answer is 1. Since this is the y-intercept, meaning b equals 1, right? We have 0, 1. Then you can use y equals mx plus b. M is 1, b happen to be 1 as well. And y is equal to x plus 1 is the final answer. Needless to say, this pair 0, comma 1 belong to the original function. It also belongs to the tangent line. It should work, and it does. We simply put means this part works. Has got nothing to how we found the derivative and the slope. All right, let's differentiate y equals 1 minus secant x over tan x. We have a fractional format. we're going to write this as f over g, and we are going to use the quotient rule of differentiation. So having said that, we start with, so we want f prime g minus g prime f over g squared. We start with f prime. 1 is 0, negative. Secant, the derivative of secant is secant x tan x. So minus secant x tan x. Times g, simply times tan x. Minus g prime, the derivative of tan is secant squared. So minus secant squared f, just inside the parentheses, put the numerator 1 minus secant x. As far as the denominator g squared, simply put tan squared x, and we are done with calculus. We are going to simplify the numerator. Minus secant x tan squared x minus secant squared x minus and minus plus secant cubed x, the denominator is not changing. Now notice, as far as the numerator is concerned, we have a common factor of secant x, so we can keep everything. The denominator is tan squared. In the numerator, we want to factor the secant out. So if we do that, the first one gives us negative tan squared. This gives us negative secant, and this gives us positive secant squared x. One of Pythagorean identities in trigonometry is 1 plus tan squared is secant squared, which means if I move the tan squared to the right, means secant squared minus tan squared. Secant squared minus tan squared can be replaced by 1. So these two, the first and the last one, inside the brackets, are secant squared minus tan squared. We can replace it with 1. And so the final answer, y prime, would be secant x. Brackets becomes 1 minus secant x. The denominator is tan squared. So that's the final answer.